So this talk is building production-grade resilient architectures with Amazon EKS. In short, is building Amazon EKS clusters with resiliency. My name is Carlos Santana. I don't play the guitar. I always have to make that joke. So you can go to the House of Blues here in Las Vegas and hear some Carlos Santana music. But I'm a senior specialist solutions architect in containers that includes EKS and ECS. And with me is Neil. He's a principal specialist solutions architect in containers, both on EKS and ECS, pretty much, right? But for today, we're going to be talking about Kubernetes running on AWS using EKS. So the agenda for today, we had a lot of topics to choose from. With 1 hour of a session, we had to choose some aspects that come together in a story around platform engineering on top of EKS. So we choose to talk about management, observability, and governance. So that's pretty much what we're going to talk today. Talking about platforms, everybody starts building their platforms and builders, right? These are the folks that are in charge of the cloud resources in the organization. And what builds a platform is building for teams. They're organized by teams. And then you have your applications that you run on AWS. And then you have your infrastructure. So pretty much it boils down to 3 aspects. You have teams, you have applications, and you have to put those applications somewhere in the infrastructure. Talking about platforms, the idea is that these platform engineers build abstractions, and they accelerate how they build these applications on AWS, providing cloud infrastructure as easy as possible with autonomy to those teams. This is a stat that by last July of 2024, there's more clusters being managed by AWS in these terms of EKS, 33% growth year over year. So the amount of clusters that folks are configuring, deploying, and managing and upgrading is increasing year by year. So that's a stat that is in there. And what are the challenges that platform teams have when they come into managing these clusters? So today we're going to look into 3 areas. One is this life cycle of the cluster, from deployment to upgrade, on how to develop a consistent process. The next one is enforcing best practices across all clusters by not monitoring them and also the applications. But for today, we're going to concentrate more of the clusters and the system-wide software that runs on those clusters. And last, providing guardrails to support the teams that need these clusters and giving them the right amount of autonomy, right? They need a cluster, they're developers, but they need guardrails. So let's start with the first topic of management. And this is how it looks like. We generally see customers with a Git repo, Git resource, some kind of infrastructure as code tooling like Terraform, CloudFormation. I heard somebody here in the audience talking about CDK, Pulumi, and others, infrastructure as code that the state lives in an object store like S3. And then they will deploy a cluster. Then they will use the same infrastructure as code tooling to deploy Kubernetes resources, saving the state of these Kubernetes resources in the same location at for example, the S3 bucket. For Kubernetes resources, this might be problematic, but for simple cluster management, not a problem at all. And then things starts growing. Then you, as a platform engineer, you start getting requests as that teams need another EKS cluster. So you copy-paste, right, that pipeline, move it on, and you get a second cluster and create a new pipeline. Then it gets to this level. So raise your hand if you have an organization that it looks like this, having a lot of pipelines, deploying a lot of EKS clusters. The growth continues. This becomes unmanageable. Too many versions of the pipeline because you're copy-pasting to track which clusters is up to date. This without thinking what is inside of each cluster, right? The resources and the application. It's not uncommon to see many pipelines in an organization. So this is a lot of snowflakes, right? Each one individually, you can say that it's an EKS cluster, but if you look closer, they have a different version. So what are the applications they have inside? And each one has an old version of a variation of a pipeline. So what are the key challenges to restate in terms of management? When you have unmanaged growth of clusters, what are some key challenges? Enforcing standards across your fleet of clusters. So now we're talking about fleet of clusters. Becomes hard to automate those deployments. When you have automation, how do you configure a single source of truth for all of them? Add-on management becomes something that gets out of control with so much open source projects. The team cannot be an expert on every add-on out there that you put in your clusters. And lastly, workload management. How to match the best instance type, in case of EC2, to a workload. And also do cost optimization on top of it. So this is something that we see from the field. Me and Neil, we work on the field with customers, probably some of you. And we work with customers that are trying to configure and deploy EKS clusters and building kind of like a pattern, or how do we serve these teams that are in the organization. So we see a lot of ways of clusters that are provisioning organizations. Templates as a service, this is on the left side. It's used by many platform teams initially, since it's a low barrier to entry. Like the platform team would be, I'll create a template, give it to the dev team, and then they will create a cluster. But this becomes hard to manage at scale. Development teams, guess what, tend not to upgrade their clusters. If you're in the platform team dealing with EKS clusters, you know that you need to upgrade them, patch them, and release new updates. If you just give them that template to the dev team, they will just run it once and then never go back to upgrade those clusters. Platform teams taking more ownership, providing a service. So let's take a look at what we advertise. So the first one is cluster as a service, giving a cluster to a team, but the platform team managing the cluster itself, making sure that they're the ones upgrading the cluster, upgrading the add-ons. Another one is namespace as a service. So namespace as a service is something that the team would have a discussion, or maybe a forum that asks the team, like, how many resources do you need in that namespace? So the platform teams can set resource quotas, and in Kubernetes, those are APIs that you can configure, or maybe limit ranges or default for requests and limits. And that way, you get a namespace created by this platform team, and then the team can deploy inside of them. And the last one is, maybe the only thing that needs to provide to the platform team is, give me an application, I'll give you a repo. And they don't know that their application is running on Kubernetes. They only care about getting their application on Git, and then the platform team takes care of taking that application, building the containers, and deploying the application, so the team gets isolated from that infrastructure management, and the team only focus on their app. So we take that last one, is very, very familiar to some of you. Who here is using GitOps? Okay. So you can relate to what are the benefits of using GitOps and how it can manage the methodology. We can build a platform on top of it. By using the declarative configuration, it reduces complexity, right? When using Git, we can track changes and enhance level of visibility, right? So we can even roll back. When you have security standards that are put automatically, increases security. So this is something that we have seen in the field with some teams that once the security teams know that they can use GitOps to have their software or policies automatically configure on all EKS clusters, they actually start learning GitOps, and that's something that I learned from the field. And when you want to be sure that if someone makes a mistake making a change somewhere, it can automatically reconcile that change back, right? Roll it back automatically. So in GitOps, it always reconciles the desired state to the current state. That's if you have automatic syncing. There's different ways of configuring GitOps, so you can have manually or automatic. It depends on your organization and the environment that you're working with. If we're going to deploy an upgrade, an EKS cluster with GitOps, let's take a look at what it looks like a bill of materials. At high level, there are three major areas to consider when you are configuring an EKS cluster for your organization. There's many more, as some of you already working with EKS, but for this instance, we're going to be talking about three of them. The first one is control plane. This is the thing that configuration of the EKS service that you can configure with the AWS API. Things like, do you want encryption on your etcd, for example? Or you want to configure cluster access management, which is a recent feature of Amazon EKS that some of you were maybe using the config map. Now you don't have to use the config map. You can use cluster access management, and that you can configure through, like I said, the AWS API of EKS. Next one is pod identity. Maybe you were using IRSA, things like that, that configures the service account with an annotation. Now we have a better, or a new approach of doing it with pod identity. That configuration, you actually do it at the AWS API on the EKS service, that you can associate a service account with a different, with an AIM role. And most important is upgrading the version of Kubernetes, like going from EKS 130 to 1.31, upgrading the minor release. That's something that is available at the control plane. And that's a lot of considerations to take, as I mentioned a few, that you will have for that bill of materials, that at some point you'll be configuring that cluster or many clusters at the same time at that level of configuration, and then it can be like one unit of change. The next one is the data plane of workers. In Kubernetes, they're called worker nodes, where you have, for example, your kubelet, your containerd. And now with Carpenter, we have much better control on how we configure the EC2 instances using Kubernetes API. So when I mean Kubernetes API, it's usually your Helm chart or YAML files. And we see a lot of organizations already have their Carpenter Helm charts that they can create their classes, and more importantly, the node pools based on themes that they can configure. And those Helm charts usually are deployed through GitOps. That's a better management that allows the team to configure the node pools that can match the workloads that when they deploy the pods, for example, that request the EC2 instance. And the last one is the add-ons. And these can be add-ons that we are provided by AWS, the EKS add-ons, and other type of add-ons that are system-wide software that you deploy on your Kubernetes cluster, usually packaged as a Helm chart that come from open source or can come from a AWS partner, a vendor. So if we're going to rely on GitOps for tooling for fleet management, we can have a process that will constantly try to reconcile the source of truth with the actual state of the cluster. That bill of materials we can discuss, we can express as Kubernetes files in Git in different specialists have visibility and control over the definition of the dependencies. So we have here like applications, infrastructure, policy, and security, all configured in YAML files. In this respect, for this slide, we're just going to name it cluster.yaml for simplicity of the workshop, of this presentation. So once you have your configuration that you have, like I said, the different areas of that bill of materials, you're changing the control plane, you're changing something about Carpenter, or you're changing something about add-on, you have that in Git. And we can have a GitOps agent reconciling, our GitOps agent in here. This is an icon of Argo CD. This is a CNCF open source project that many customers actually use. There's other GitOps tools that reconcile these resources into the Kubernetes cluster. On this cluster, we can have cluster Kubernetes controllers like ACK. Let's have ACK there. ACK stands for AWS Controllers for Kubernetes, a tool that is open source and is fully supported by AWS. This is the EKS team providing this open source project. So if you have any issues or you have feature requests, you can just open a Git. In the Git repo, you can open an issue and request that, and the team will look into it. And also, we have a channel in the Kubernetes Slack. So for example, now that we have ACK could be something that can configure with Git that will get you an Amazon EKS cluster. So this is the first layer that I was talking about the control plane. Then we have kind of inception of like deploying Argo CD again inside the Kubernetes cluster, and that Argo CD is deployed there to have some isolation. That way, that Argo CD can only care or handle that Kubernetes cluster, and it will act as an agent that it sits down configuring that. Then the Argo CD is the one managing that EKS cluster. So it would deploy the add-ons. For example, if you have open source Carpenter, it would deploy Carpenter that will give you those nodes that for your workloads. And if your workload needs access to an AWS resource, for example, an S3 bucket, you can have ACK installed inside that cluster to deploy the S3 bucket that your application needs. So this is a typical architecture that is used by folks that are using GitOps to configure both the control plane, Carpenter for the data plane, and then the add-ons. And this way, they can do everything defined in Git as YAML files, declarative configuration. So let's talk about now a little bit more about resiliency, right? So now we can build a cluster, we can use GitOps, we can use open source tools, we can use AWS APIs, we can use open source tools like ACK. So we have a lot of clusters, but without velocity, that as you heard before, many organizations have multiple clusters for different reasons. It could be for different regions, different teams, different AWS accounts. Without velocity, they fall behind, cannot upgrade everything serially. It will take forever to make one change if they have to upgrade everything serially across. Some organizations have hundreds of EKS clusters. Upgrading in batches, however, needs safeguards in place to ensure resiliency and availability. So this is kind of like the misconception that people think that they can set the desired configuration and suddenly every cluster around the world gets updated automatically at once. That's not something that is best practice. It doesn't give you high resiliency. So consistency of components and versions help and scale. So this is how EKS team presented last year in reInvent 2023. Have massive amount of EKS clusters, like I mentioned in the stat. Year over year is growing the number of clusters that we manage. For example, when there's a patch released for the KUB API server, KUB API server is a component that runs on the control plane that AWS takes care of that you don't have to worry about. But we have to patch it. If there's an upstream, what I mean upstream is the upstream Kubernetes project. There's a patch that needs to be rolled out across all our EKS clusters around the world. That's something that we take very seriously. But like again, we have velocity and resiliency both together on that balance. So grouping clusters in cells help manage the blast radius. We have the bake time between waves. We call them like one wave of a number of cells that get upgraded, and this time that is the bake or soak time that people refer to, decreases as the amount of cells increases. And we have different levels of tests that are done between every wave of waiting for that soak. And every cell could be about 1,000 clusters. And there's a YouTube video about this talk online. So applying this pattern to your own EKS clusters in your AWS accounts in your organizations, we can have some type of fleet management that we can have updates be rolled out across your organization, but in a resilient way. So how this looks like obviously depends on your organization. And in this example, what could be a cell? A cell could be 1 unit of work. It could be one cluster, for example. And for this, to explain these concepts, we're going to use like one cell is 1 cluster. So how many cells you can do in one wave? Well, it matters managing the velocity and resiliency. As you progress, the confidence tends to increase. So for example, as you roll out one of the add-ons, like I mentioned, right? Or you're changing a Carpenter class configuration that is used across all your EKS clusters. You have more confidence as you start patching those clusters, and then you diminish the amount of time that you wait for those, and you can pick up more cells as you upgrade. So in this example, we have Waves Sandbox. That is the one cluster that the platform team uses for testing their change. If you are doing platform engineering, usually you call them a sandbox. And you can have waves on one single environment. In this case, we're showing different environments. So we have dev, and then you do staging. So in staging, you do more clusters. In production, you can have not update all clusters in production as you increase that, but you can divide how many clusters you have in production to update. So in this case, we have prod 1 and prod 2. Maybe they're divided between regions, or maybe they're divided by AWS accounts. It depends it really depends on your organization, but the idea is as you dynamically increase the number of cells on a wave, you decrease the amount of time that you wait for that. So in practice, let's take an example, a concrete example of this. So we already talked about the cluster.yaml that defines your bills of materials. If you need to change something, for example, upgrading an EKS cluster, you will push that into Git. Then you have a rollout. And then this rollout could be a pipeline, a custom pipeline that you write. It could be a process that you follow manually, or it could be a combination of pipelines and manual process that you use, something like a ticketing system to follow the change management. But if we're using a tool like GitOps, we can use Argo CD to orchestrate that rollout with Argo CD. So if we take wave 1, you will do your checks. So before upgrading, you can automate the checks to see, like, can I do the upgrade or not? And then once the check pass, then you actually do the update. After the update, you will have your tests. And these tests could be related to the specific change that you do, or it could be a test that you always do regardless what is the change that you did. So the change could be at the control level, a control plane level. It could be at the data plane level, like a change in Carpenter, configuration of Carpenter, or it could be one of the add-ons, for example, the VPC CNI or any open source project that you have as an add-on. Then we have the soak time, and the soak time is the amount of time that you're going to wait. And in here, you're going to start monitoring of if things are happening, like give it enough time to monitor that the system is healthy to move to the next wave. What's the next wave? Wave number 2. In this case, we increase the amount of clusters by the number of cells when we do the same test again, right? We check and we test and we soak, and the amount of time that you wait, it decreases. And it continues, and then you're orchestrating with Argo CD. So let's take a look at if you are using Argo CD, or you could use another tool, but in this case, I'm going to take a concrete example because people like to see concrete examples. So this is using Argo CD, and we're going to look at what it means to check or the precinct. So Argo CD has a system that you can configure precinct hooks that you can, it's a Kubernetes resource with a specific annotation, and things that you can do here is gates. Like checking that, for example, using Amazon EKS Upgrade Insights, there's an API that you can call to see what are the things that you need to do, or if everything's green, to go ahead and continue with the upgrade. If not, you will stop. The other one could be setup, something that you need to set up before you actually do the upgrade. It could be a migration to a database, for example, if it's for a workload. Or it could be something to configure secrets that they need to be there. Or it could be another add-on that needs to be healthy before you continue with the upgrade of this next add-on. And the prereqs could be CRDs, CRDs that need to be installed. So you always have the same precinct hooks. Doesn't matter if it's a upgrade or maybe it's a deployment. Some people use the same hooks. Then it goes to the actual deployment, which is Argo CD to do the dynamic upgrades. And then this is where Argo CD talks to the Kubernetes APIs, and you leverage that. And Neil is going to talk more about those hooks. But then after the hook, we have to do our test that we mentioned, right? So Argo CD also has a post-sync hook that you can do some validation on the environment, like some functional tests to see the health of the add-ons are correct. Maybe the EKS upgrades are correct. Maybe going back to Upgrade Insights. You can also do async tasks, like launch a pipeline, for example, like something in Jenkins. Or it could be Argo Workflow if you're using Argo Workflow, which is a CI/CD pipeline or workflow orchestrator that you can run inside Kubernetes, or just notifications that everything went well. And with that, I'm going to pass it to Neil to talk about the next 2 stages of Observe and Govern.
All right, good morning, everyone. So thanks, Carlos. He's, I think, hit his CNCF bingo card for the morning so far in the first section, but I get to talk about the slightly less interesting stuff. But still, we're going to switch gears a little bit. Now that we've gone through Carlos's section around how we provision and upgrade these clusters using our nice GitOps-driven process, we'll switch gears to a couple of other areas, and we'll start with observability here. So I don't think there exists an AWS presentation that has the word observability without having this slide in it, but it's a catchy quote, so I threw it in here. At the end of the day, regardless of whether we have one cluster or 100 clusters, things are going to break. We need a strategy to find issues, detect them, help us remediate them. And if we can't do that as a platform team, then we can't operate a service that our developers can rely on. So both in this section and the next section, we don't have time to do Observability 101. Instead, what we're going to do is focus on specifically some areas that we've seen come up again and again with customers, that they struggle with these particular areas when they're operating clusters at maybe a larger scale. And that could even be when you start to reach 10 clusters. These issues can start to manifest pretty quickly, but we'll go through these one by one and just take a look. So the first area is going to be roles and responsibilities. So Carlos already mentioned at the start of the presentation that at least most of the customers that we talk to when they start to manage lots of EKS clusters they tend to be organizationally structured around a platform team and an application team. Is that necessary? No, but it tends to be what we're seeing in the field as an effective way to scale your use of EKS across lots of clusters. Now, the platform team is typically not just a cluster factory, right? The name suggests they typically offer more in terms of some sort of shared capabilities that the development teams can rely on. In the observability sphere, that could be managing the observability infrastructure itself, but they can also, in some cases, maybe even pre-provision dashboards and alerts as they onboard application teams to get them up and running quicker. By the end of the day, the platform team is responsible for keeping those clusters up and running. They're not building the clusters and throwing them over the wall. That's kind of the opposite of what we're looking for. We want them to provide a service to the development teams where the developers are customers, right? That's how we think about it. It's that whole idea of platform as a product. And we need an observability strategy that reflects how we do that. So in order for the application teams to trust the service, and the trust is a critical part here, and we'll talk a bit about that later as well, the platform team needs to be monitoring the signals coming from the clusters constantly. As the application teams are monitoring their workload signals, the platform team is working hard to monitor dashboards and alerts with their instrumentation coming back from the clusters and providing that reliable service that the app teams are depending on. So, and many of you have probably already gone down this journey. You know, it's not unusual for us to see customers start off just by investing heavily in dashboards, right? Dashboards are easy. They look great. You get your telemetry into your system, you install some dashboards, and you're doing observability, and everything's great. You can find your problems. But obviously, this doesn't scale very effectively pretty quickly, right? As soon as you start to monitor a handful of clusters, you're not going to be sitting staring at dashboards waiting for a problem to happen. You need something that scales a bit more effectively than that. So pretty quickly, folks will migrate to something along the lines of relying significantly more on proactive alerting. As a platform team, again, for that aspect of trust, we don't want, ideally, our customers to even notice there's a problem if something breaks in one of our clusters. We want to know about it and hopefully fix it before they even know that it's there. We definitely don't want to be relying on them telling us that it's broken, because that is just fundamentally how that trust starts to erode in the platform team and the platform. And this starts to dovetail into a topic which we talk about all the time, which is platform adoption. If the trust erodes between the platform team and the application teams, then you quickly run into an issue where they're not going to want to use your platform, and you need to keep that trust by having these proactive alerts and having a very proactive approach to keeping those clusters up and running, regardless of where on that spectrum that Carlos showed you land. Even if you're just vending a cluster to them, in the patterns that we're talking about here, it's your responsibility to keep those up, so you need a solid system here. Alerts also, just having alerts by themselves, you can end up in a couple of different holes here. Alert fatigue is an old term at this point. Everyone knows it. So having the right alerts is obviously very important, but also having an alert by itself doesn't tell you to fix the problem. And to scale your support organization, you need to have runbooks tied effectively to your alerts so that you can scale your platform team and that folks can fix the problem at 2 o'clock in the morning when they get an alert and aren't scrambling through documentation. Also, something that I didn't put on the slide here, but as we increasingly start to see automated remediation start to become more and more of a pattern. I know I was at KubeCon a couple of weeks ago, and I think the thing I saw the most on the vendor floor was ops remediation. Vendors were now pretty heavy in the expo. If you don't have runbooks defined, then you're not going to be able to automate these processes eventually. So this is something which people have been doing for a long time, but as we start to see this automation trend increase, if you have runbooks, increasingly there are tools coming up that can take those runbooks and potentially apply them automatically for you. So you've now got a new motivation to have these runbooks actually defined ahead of time. And finally, taking this, so far we've talked about things which probably aren't directly related to necessarily managing all our clusters, but this nice continuous delivery flow that Carlos gave us earlier, from my perspective, it's basically a prerequisite to have this feedback loop in your process to make this work, right? This is how, as Carlos said, the EKS service team operates, is as they're rolling out through those cells and through those waves, the proactive alerts become something that is telling them whether or not their process should continue or not, right? They're not sitting watching dashboards, as you can imagine. So the other thing, obviously, as we go through here, Carlos talked about tests. So it's not unusual for us to talk to platform teams who have maybe built a way to test and upgrade in their sandbox cluster. Maybe they've got a small cluster they use for functional tests. And that will uncover several issues, but as you progress through your waves, when you start to reach staging and deployment, at the end of the day, it's no mystery. You're going to uncover issues that you just can't find in dev. And you can continue to iterate on your tests and continue to find those problems earlier on, but at the end of the day, the soak period isn't useful unless you're monitoring something and you're alerting on things, ideally in an automated way that will effectively sort of act as a circuit breaker for your process, right? So this robust set of alerts really just ends up being a mechanism we can use to cancel a rollout as it's going through if we start to run into problems. So this sort of feeds back into that whole continuous delivery process. This is probably the question I get asked a lot, which I wish I had a better answer for. I wish I had a list for you of what you should monitor and what the alert thresholds should be. If anyone has one, please send me it. But at the end of the day, a lot of you folks are running Kubernetes already. You know how many components you can install in a cluster. You know how many different workloads you can have running in a cluster. It can be pretty difficult to figure out a set list of things that we can just tell you, monitor this stuff and you're going to be good. Some of these things, there's some great stuff online you can use as benchmarks. But I think instead of trying to give you a list, really what we want to talk about here is just emphasizing the breadth of what you have to monitor to effectively do this, to have trust in your process that it will short circuit your deployment if something goes wrong. This can be anything from, did the error rate on your Kubernetes control plane increase after your upgrade? Are your nodes coming up healthy? Did core DNS latency increase? Core DNS still a problem in 2024. And if we can we understand if our customers' workloads are degrading if we've done an upgrade, right? Did the error rate on developers application ABC experience more latency or experience higher error rate? And if we can especially get that sort of information, we understand not just the health of the cluster that we're providing, but the health of the experience that we're giving to our developers. Now, something which recently launched, which is related to this, would be that we did, in the last couple of weeks, launch the improved EKS cluster control plane monitoring, where you can now get a whole bunch of extra metrics out of the control plane, which is something you should definitely check out. We'll throw a link in some of the related resources at the end of the session. But that gives you a whole set of metrics that you didn't previously have, as well as extra mechanisms built into the console around things like looking at your audit logs and stuff like that to identify issues. So that's been a great recent launch which you can start to leverage. Now, not strictly observability, but we're going to throw it under this umbrella is maybe switching off a little bit, which is cluster inventory. So this is less around finding issues and troubleshooting issues, and more around how do I get a picture of all the clusters in my organization, especially as it starts to scale, and especially as it starts to scale across regions, but accounts and whole AWS organizations, right? It can be tricky to navigate between all the console screens and sort of keep track of what's going on in an aggregate view. There's lots of ways that you can solve this. We see people doing it with vendor tools. We see them using Grafana and observability tooling. One thing that we've started to see is folks using developer portals like Backstage. So I'm a big fan of Backstage. If you've seen any of my stuff before, But we have seen some customers, especially Kubernetes native customers, starting to use the ability to ingest information about their EKS clusters into developer portals, whether it's an open source one like Backstage or vendor products that kind of provide the equivalent, so you get that cross-account, cross-region view of all of the clusters that you have there. I think this is probably a better option than some of the other approaches that we see, like building your own portal from scratch as a custom web app, which a lot of people were doing with developer portals before Backstage. But this is something that I think we're starting to see some of our more advanced Kubernetes users take advantage of, as well as an aggregate list of all our clusters, especially tools like Backstage, which are super flexible, gives us the opportunity to customize and start to aggregate information, not just from EKS, but from related systems. So we could start with basic stuff, right? Maybe our account ID, our AWS region, EKS version, the add-on version is just basic stuff we can pull from the API and maybe some other places. But then we can start to add in extra information, like a cost tab, where we maybe pull the information from kube cost or open cost. Maybe we start to provide feedback on policy violations and findings right in Backstage and pull that into the same place. Maybe we show the SLOs for the cluster, so dev teams can see what the historical availability of their cluster has been, right? Again, not a monitoring tool, but just a heads-up display of how has this cluster been performing that users or managers or somebody else can just take a look at to get a heads-up view. And then if there's information that we don't want to rebuild all of our other tools in developer portals like Backstage, we then start to provide out links to all the places that we need to go, right? We're trying to get rid of that big bookmark folder that you have, where especially if you've got 100 clusters, you're going to have a pretty bad time in Chrome trying to keep track of all this stuff. So we provide deep links into all the places for a given cluster, so it becomes not just a single pane, but also a launching point off into all the other systems that you need to actually run your cluster, and it gives you just that basis for being able to navigate through across your fleet. The last thing that we find this useful for is relationships. So it's not unusual for developer portals to let you express relationships between whatever they call items in their catalog. And in the Backstage case, it would be entities. We can start to model things like what workloads depend on a given cluster. Then the team ownership we already have modeled, typically in our Backstage. At this point, we can then start to model which clusters are dependent on each other by understanding which workloads depend on each other. And we can start to build up this graph of metadata about our clusters, our workloads, and our organizations that we're not talking about pods and deployments, we're talking organizationally about how these things fit together, so we can start to understand the impact or blast radius of changes, potentially, if we needed to figure something out. Or what would the impact be if this cluster in the picture here went down in terms of not just the workloads and the teams, but in terms of maybe downstream clusters where the workloads are interlinked. And we can start to do that by building up this graph. And this can all be done automatically, right? We don't need to do this manually. Just last week, we open sourced a new plugin for Backstage where you can now ingest AWS infrastructure straight into the Backstage catalog through AWS config. And that means that there were some existing plugins which let you do parts of this before that were a little bit patchy in terms of specific AWS services. Now anything that lives in config you can pull straight into Backstage, including EKS clusters, and then map them through in terms of dependencies using things like tags to build up this graph completely automatically and start to get an idea of how this fits together. So in a similar vein, Carlos talked at the beginning about guardrails. So talking about governance a little bit, one of the themes that Carlos discussed earlier was consistency, right? When we start to talk to customers that have 100 EKS clusters, you can't necessarily, well, it's harder to manage those if you don't have a measure of consistency. So what Carlos talked about earlier gave us that consistency at the EKS cluster layer, right? We're getting all of our clusters up, we're getting our nodes up, we're getting our add-ons installed. But unfortunately, we've got some pesky developers actually putting stuff in the clusters. And depending on your organization, you may or may not have control over what that looks like, depending on the spectrum that Carlos talked about of where you end up from vending a cluster all the way through to a platform abstraction. That gives you more or less control there. So really in any of those cases, governance really becomes a key for achieving that consistency as we scale, especially as we're trying to balance autonomy, right? Between more autonomous dev teams that have opportunities to do more in their clusters versus maybe a more guardrailed approach where we are helping developers figure out what we should be putting in our clusters. Now again, this is not going to be a policy as code 100 session. Instead, we want to talk a little bit more about how we're seeing people apply this specifically for problems at scale. But just as a quick primer, obviously, for everyone, policy as code engines like OPA Gatekeeper, Kyverno are exceptionally popular tools that you can get from the open source world that will allow you to essentially express policies as code. For example, Kyverno typically is a YAML file. And those will often, you can enforce them in different ways, right? So a pretty open one would be you apply the policy in the cluster, a set of controllers are reconciling against changes that are made, and you can flag a policy report of everything that violates the policy that needs to be addressed. A little bit of a harsher approach is that you can use things like admission control to simply block changes to the cluster that don't apply your policies correctly. Now, certain organizations are willing to apply that and others are not. Again, on that autonomy scale, that gives us a nice way to just stop things going in full stop that we don't want to be there. But oftentimes, development teams will say that it slows them down, and in many cases it can, right? So you've got to balance about which one of these that you're going to apply effectively to your organization and the nature of how you're building your platform. But specifically, what do we see as some friction points, similar to observability, where policies start to come into the picture? So similar to what to alert on, we have what policies should I write? And this is potentially even more of a blurry area because I don't know what your policies are. There's certain natures of policies that we have that are probably what I would consider a solid baseline, right? Those ones around, say, security. Are you running read-only file systems in your pods? Are you locking down, adding extra capabilities and running as a root user? All those, I would say, boring things that are kind of like your foundational set of policies that you should really be putting in place. Probably some basics around things like, are you tagging or labeling all of your pods correctly so you can do chargebacks for cost as you scale up, because you need to keep your costs under control. Where we start to see this specifically come into play for larger fleets of clusters, firstly, keeping rollouts on track. So I've talked to so many customers where they're, call them a Kubernetes team or a platform team, are unable to upgrade clusters because of what developers have deployed to them, right? As Carlos said about giving folks infrastructure as code templates and them never upgrading their clusters, deprecated APIs, deprecated CRDs, pod disruption budgets that basically get your node rollout stuck in the mud. This is where we immediately get into the discussion of policy as code, and you have to be able to provide guardrails for people so that your cluster rollout stays on track. You're not going to be able to go to every developer team and tell them that they have to upgrade their CRDs if you're running hundreds, 200 clusters. It's just, you're going to spend all of your time doing that. You have to start to push that process left and keep them on the rails. And I know it sounds obvious, but my hope here would be that if you are in a similar position, or you think you might be in a similar position, this is a problem that a lot of customers are having, and the solution is unfortunately this, right? There's no magic technical solution to this problem. A lot of it is organizational, as it probably comes across. Policies give us a way to implement an approach to solve this, but this is a recurring problem that we see people having, and you just have to plan for it. So if you are having that problem and are struggling to get people to get on board with how to fix it, this is really what we're seeing. The other aspect is availability. We've talked to customers where they say they can't upgrade the clusters because in the development clusters, their application teams have only deployed with one replica, and when they upgrade the cluster, the teams complain that the cluster went down and the platform's not stable. This can even go up to staging and production if they haven't used pod disruption budgets. And obviously this impacts more than our upgrades hurting your cluster. If there was other issues with the cluster itself, it will also manifest. But if we're going with this process of regular upgrades, we want to keep things rolling, we're constantly changing stuff, we want flexibility there. If these things are not in place, again, that trust, even if it's just the perception of trust eroding in your platform, you're going to run into issues again with adoption, teams complaining, and it's not necessarily fair, but using policies has to be one of these tools that you leverage, not just for the resiliency of keeping your apps running, but for making sure that you can apply these upgrades regularly without getting negative feedback on the platform that you've built and the process that you've spent all your time building that Carlos talked about earlier. In terms of managing policies, Carlos has already done all the hard work for us here, right? We've already got our GitOps-driven process that can take whatever artifacts that we want and push them out. When you start to get up to scale, what we're really trying to do here is manage consistency, again, across our clusters, but we have to be able to handle variation and we have to be able to handle exceptions. So to get that consistency, one pattern that we see often is just, it doesn't matter what cluster it is, you have one Helm chart of all your policies and it goes everywhere, right? That's your baseline. Starting to patchwork, deploying one policy to one cluster and one to another will work early on, but as you start to get up to a larger scale, you're going to need to just start to say, I'm throwing everything everywhere, and then start to be able to apply options within your Helm chart, say values files, that allow you to enable or disable certain policies. Maybe you have different policies in your web services cluster than you have in your data cluster, for example. So that could be one sort of maybe bar that you use there. And then we just roll that out with our GitOps-driven process to all of our clusters. It's just something else that we deploy. In terms of exceptions, so tools like Kyverno have exceptions as a first-class process. You need to be able to handle this, right? So it could even just be as simple as you have that third-party software that just won't run if it's not run as a root user or something like that. It's, we all have one. So being able to handle exceptions is something that you need to be able to do eventually, but we want to be able to do it in a way where we can continue to have this single artifact that we deploy out. So making sure to plan for exceptions depending on the tooling that you're using is something that we want to make sure we plan for. Now, I talked about earlier around the different ways that you can run these policy as code frameworks. The simplest being we're just going to assess the resources in the cluster and maybe create a report. So Kyverno, for example, will drop in something like a cluster, a policy report into your cluster when it does its assessment. At first, you can probably just take a look into the clusters to see what's not running. But once you start to really scale out your EKS fleet, you're going to need something a little bit more aggregate in order to effectively police these violations of your policies. So Kyverno, as an example, has the related project of the policy reporter, which you can install in your cluster, aggregate all your findings into a system like S3 or Elasticsearch or Security Hub. And that gives you that single pane where you can aggregate all those violations in one place. So we have an example blog post for both OPA and Gatekeeper, which this screenshot was derived from, where we're shipping all of our Kyverno findings straight into Security Hub. Now we can search them. We can search by account, by region, by cluster, maybe even by workload, if all the right metadata is there. And then we can rely on whatever other features we want from Security Hub. Say remediation workflows and all that sort of stuff is things that we can build off of to effectively start to actually not just detect these violations, but have a system around remediating. So with that, we're at the point of the talk where we're going to start to wrap up. So really, this reflects the three themes at the start of the talk that Carlos talked about. Applying GitOps effectively is something that we're really starting to see as a trend from these customers that are building out larger fleets of EKS clusters. GitOps, whether it's a prerequisite or not, is really the trend that we're seeing around technology and things like Argo CD, in some cases Flux, and also piggybacking on top of GitOps with Kubernetes-driven infrastructure provisioning, whether it's ACK, crossplane, and technology like that. Investing in proactive monitoring, right? Of being alert-driven, not just so that you can detect problems, but so you can feed it back into that GitOps process, so that you can have this largely hands-off and you have confidence in the system that you're building and the process that you're using to keep your clusters updated. And finally, we want to use governance as our key to scaling. There are some problems that we keep seeing over and over again as customers try to manage EKS clusters and start to scale up their adoption, that policies are effectively the key to, and planning for that and committing to that being the solution is something that we have to talk to customers about pretty regularly. Related sessions this week. So this has been pretty high level, right? We've been talking themes and concepts. Carlos has put together a workshop, which is being run twice this week, once tomorrow and once on Wednesday. This will also be available on GitHub, and the link is in a link which will be coming in a couple of slides, but that will actually give you hands-on experience in what we've talked about today.
In the three areas of you have experience of managing multi-clusters with GitOps using Argo CD. In the workshop, we have an example of using Terraform. A lot of folks use Terraform So the pattern shows you how to manage Terraform for AWS APIs and then Git Argo CD for the GitOps. So a lot of folks have difficulties how to put those two tools together. So we have an example of that. And then going into management of observability of like a lot of platform teams worry about the applications observability, which is that's like net good, but forget about like monitoring the observability of the add-ons. Like how is the open source carpenters doing? How core DNS is acting? VPC CNI, subnets. That's observability that the platform teams owns. So they have to be aware of that. And then ends with some learnings about policy management. Would you be using Kyverno? So we'll be using the Kyverno and Kyverno reporting, configuring actually this example of the security hub. So you have hands-on experience on that. So get there early if you can.
And it will be available it's already available.
Yeah, and everything is on GitHub, open source, so you can start looking at it, taking extracts of it to apply to your own organization.
Next, there is KUB404. So this is a talk with Adobe and some folks from AWS on how they've built scalable platforms with EKS. They've previously done some talks at KubeCon and some other stuff, CNCF-related talks around how they do this, and they're applying some of the principles that Carlos talked about around pre-flight checks and post-flight checks and all that kind of stuff, right? Yeah. So definitely a talk I think is worth seeing, because you'll see, again, some of the themes around platform building, but also how Adobe is doing in practice, so definitely recommend that one. And then finally, there is some chalk talks that are getting done on playing off things like infrastructure as code, GitOps, CI/CD, the different options that you have, pros and cons, and what maybe you should be considering for your organization that you can catch, again, a couple of times this week, which will also be great sessions. Oh, I'm pressing the wrong button. In terms of extra resources, so EKS Workshop, hands-on labs if you haven't already done it. We're continuing to evolve that with the new launches as they come out. We're running that a couple of times this week, but we didn't include on the extra sessions. But if you want to run this yourself, you can run it self-service. We can also run this as what we call an immersion day. Talk to your account team. You can have specialists come in, help deliver this to your teams and learn EKS hands-on. It's very modular. We can tailor it to your organization depending on what it is you want to learn. So definitely worth taking a look if you haven't already. Best practices guide. So many of you will probably already be familiar with the EKS best practices guide. It's been around for a while, but recently we did take what is this great set of knowledge for day 2 operations, and it's now officially part of the EKS documentation. So all the same great knowledge, but it matches the docs, and it's all in the same place now, so it could be easier to find. And finally, who doesn't love a badge? Get your badge, put on LinkedIn, that kind of stuff. I don't have mine yet, do you?
Sorry?
Do you have your EKS badge?
Yes.
Oh, okay, I need to catch up. This is a link to a GitHub page. You'll find all the Kubernetes sessions in this GitHub. There'll be a directory for each Kubernetes session. It'll mostly be links to resources. We're not necessarily putting code here. A bunch of links to stuff that you can look at related to each session. So that link should take you to our folder, but that repository, you can pretty easily find your way around it. We've added some links in there to some of the stuff that we've talked about, some of the extra sessions. So
yeah, the main README has all the KUB track that we are part of, like EKS KUB track.
Yep.
And there's other workshops. If Neil mentioned Backstage, there's also some workshops that you're going to get hands-on experience with Backstage. I think it's KUB404. KUB404 is the, if you want to get hands-on on doing EKS and Backstage, and there's other ones of GenAI and Backstage.
Yes.